Okay, so Starlink power system, there's a two kind of battery we can use in the system. Traditional way is use a lead acid battery. There's another way is use lithium battery. The each we're insist using lithium battery. There's a specific reasons. Now we're talking about a solar powered Starlink project. We're not talking about a small independent civil usage scenario. We're talking about a massive deployment with like a nationwide rural area coverage, this kind of project. When our customer is running a massive deployment project, there's many things we should consider. It's not only the realize the project, but the real thing is we need to consider long-term operation costs, not like only the capex. So think about it. If you have a Starlink system, the power consumption plus some load, Starlink is like a let's say a typical power consumption from 50 to 150 watts power consumption plus some other load. Let's say you have 150 to 200 watts around. So normally you have to consider a very big battery like a 4,800 watts hour or something. If we use the lead acid battery, that will be a two pieces 12 volts 200 Ah battery. That's very big. That's like a 100 kilogram something. Then remember that you have to transport the battery in the rural area because think about it. Think about it. It's a massive deployment for the Starlink project. Normally, it will be in rural area, right? So it's if it is a massive project, massive deployment project, it's not as if independent usage. You have to transport a lot of battery, very heavy in the rural area, and most of the scenario for the installation of the site will be on pole. It's very difficult to install such heavy things on the pole because you see that in the rural area, if you want to install something on pole, you have to get some like a crane or some very heavy equipment, right? But remember, it's in rural area. How you get it, it's a problem. So let's say that the installation will be very complex. Second is the transportation will be high, the cost will be high. But if we change the capacity, same capacity to lithium battery, something like a 300 kilogram, it will fix the job. So much more easier to install on the pole and transportation cost is lower. Second is, as we mentioned, operation cost is very important in the massive deployment of Starlink solar project because you need to make sure it works based on specific SLA or let's say KPI. Because, for example, a rural area coverage project launched by a government, this kind of project must have some SLA or KPI that to limit to make sure that the service provider match the SLA, right? So you need to monitor the battery then, because for example, if you use a lead acid battery in the you configure the battery in the rural area and then you run out of the battery capacity, then you don't know what happened. You will receive the complaint from your customer, then it will affect the SLA. Then what will happen is you have to send the engineer to be on the site, then to find out what happened. But most of the case is run out of battery. Second is if it's a massive deployment for the Starlink project, you run out of battery cycles. How do you know? Now, if the site quantity is a little big, 100, 200 sites in the rural area, worldwide, rural area countrywide, how you find out? Site survey. The cost is very high, right? So for lithium battery, you can embed with a BMS, So for our solutions, we embedded the BMS and report to our software platform, then we will have the control for all the status of the battery. For example, when we run out of battery because of the continual raining days, we will know it, and then it will not affect our SLA and the KPI. We can just report our government customer that, hey, run out of battery. And when the battery is run out of cycles, we know it, So we know which side run out of cycles, and we can get there and change the battery. That's it. So compare with this part, the operation cost and site survey chance is quite different, right? Third is the battery temperature tolerance. The lead acid battery has 20 to 25 degree centigrade the temperature tolerance. Lithium battery can work higher, much more higher. Well, this make a big difference because you see that lead acid battery only have 1,000 cycles. No, 600 cycles. And then when the temperatures get higher, the life cycle is much more lower. So probably 1 year, 1.5 years later, will run out of battery cycles. Then you have to go to replace it. And then it's very heavy, see? So you transport it, replace it, what is the cost? At the beginning, it seems works, but 1 year, 1.5 years, 2 years later, what is the cost you replace it? But if you use a lithium battery, first, because the very good temperature tolerance, it can go 65 degrees centigrade, and so the temperature outdoor has no problem for it. Second, its life cycle it goes 2,000 cycles to 6,000 cycles based on what kind of battery you use. So it has a 5 or 10 years long lifetime. So compared with all of this, the TCO is quite different. So that's why the off-grid Starlink solar system, we are talking about the massive deployment with the nationwide coverage, this kind of project. Obviously, the TCO is quite different. So that's very important. We should understand.